Good morning, Tulsa Welding School family. I'm Bryan Hatch, pipe fitting program specialist, Tulsa Welding School, Jacksonville, Florida. Today I will be discussing with you the rigid 535M. M stands for manual. This is a machine near and dear to my heart. Though it looks like an industrial piece of equipment, this is truly an ATM machine, because if you put a little bit of work in, money comes out. Feel free to do a checklist. As a pipe fitter, welder combo, I've been extremely successful in my endeavors in my career. Financially, I've never been laid off, and I attribute that to the fact that I could do multi facets. This is a 2-inch piece of carbon steel. I'm going to show you how to cut, thread, and deburr utilizing this machine. The rigid 535 is good for 1/8 inch up to 2-inch stock. Once again, capable of cutting, fitting, and reaming. It also can do reverse threads. This is truly what is called a floating machine. There are a lot of machines that clone this, that mimic this, but don't let aesthetics and price fool you. There's no machine that equals the rigid 535M. It is a free floating machine, meaning if the pipe is out of round, when I'm threading this pipe, the dies themselves will travel with the pipe to accommodate that. An extremely significant function of this machine. So what I'll do without further ado is feed my pipe through the rear of the machine. I'll bring it out and I'll probably give myself at least 6 inches, which gives me full capacity of utilization of all of its functions and still permitting myself travel, because I don't want to have to readjust. So once I cut my pipe with the cutter, I want to be able to thread it without having to readjust. And that's given that I've already gotten my pipe cut length. So the first thing I'll do is I will lock it in place in the back, just a simple tap. And what this affords me is it holds the pipe from the back. In the front, we have what is called a hammer lock. So I can take it and it hammers. Once again, free floating, but it locks the pipe in the front and the back. What this does for me is when I use these functions, the dies or the cutter, this pipe here will actually rotate without spinning inside of the machine itself. This machine has 3 functions: forward, off, and reverse. It has an oil bath and an oil catch, and it has a debris catch tray. This catches the metal shavings, which is, it's imperative that you utilize this because you don't want these metal shavings going into your sump and contaminating your oil. The oil will sit in the oil bath, which must be at a sufficient level for the pickup tube on the bottom to pick up when the machine is running. If in the event that the machine is not lubricating, the machine must be put in reverse to prime. And I will never thread or cut or deburr in reverse. The only exception to that rule, if I'm doing reverse threads, I can utilize that reverse function with the threading dies only, and that's only for reverse threads. In this scenario, we're only using right-handed threads, forward motion. So to ensure that I have lubrication, I ran it in reverse to prime the pump. Now when I pull my die down, I should see oil coming down through the threads. And I do have lubrication, so my machine is ready to use. Now the rigid 535M is very simple in nature. Anything that is brought forward is going to be employed for use. Anything that is pushed backwards is not going to be used. So, in this case, I measured my pipe and I have my cut mark. What I will do is I will bring down the cutter, which again is free floating. Free floating means if the pipe is out of round, this actual cutter will compensate for that. It will move forward and backwards to compensate for out of round. And that function is very unique to this machine. The Imperials do so as well, but the 535M does everything better. Now, as I roll forward, I'll step on my foot pedal and I will add a little bit of tension. It only takes a few fingers. You don't want to bear down on this, because what you'll do is you'll flatten out your cutter, and you don't want to do that. The way this operates, it doesn't actually cut. It displaces metal as it rotates and you give it tension. It displaces metal, ultimately resulting in a break, which is why we have to have a reamer, because it will close up the pipe ever so slightly and leave a lip. All right, so we're moving forward. You can see that it's moving up and down just a little bit, which tells me my pipe is a little out of round. And again, the rigid M535 compensates for that. And we have a clean break. Now I'll lift this out of the way, which means it's not in use. And I can see a little ridge inside. And the problem with that is when I assemble any piping system, these little ridges can break off or cause an obstruction. And if those little pieces of metal break off, they can eat up hydraulic systems, they can eat up pumps, they could eat up whatever medium this piping system is going to supply. So while I'm here, I will go ahead and deburr that with the machine, because it's a lot easier to do that than it is to do it later by hand at the time of assembly. Now, I can push my retainer lock clip forward. I can slide my deburring tool forward, which gives me a longer reach, which I will have to retract again when I utilize the threader because it will be in the way. And once again, this is only used in the forward motion because the cutters are facing backwards. If I run it backwards, all it will do is dull my cutters and not achieve the removal of the burring that I'm hoping to obtain. If you'll notice, I'm wearing a thin glove. I don't want to wear anything, any chains, any neckties, or any dangling sleeves that could get caught up into this machine. This is a high torque motor. It moves at 53 revolutions per minute. That's for the 535. The 4000 series moves a little bit slower because it does larger diameter. As I stated, this is only good for 1/8 inch to 2 inch pipe. Moving forward to deburr, you'll apply just a little bit of pressure. It doesn't take a lot. Now, how much or little I deburr is up to the craftsman, but I will caution you that especially with your thinner wall tubing, you have to use this cautiously because you can see it creates a chamfer which eats up into the material wall thickness just at the end, but you don't want to thin it out to the point to where you've reduced the material thickness of the wall. All right, so I've got a good square cut. I have my pipe deburred. Now I'm going to bring forward my next tool. I've retracted my deburring tool, and I'm going to bring forth my cutting die. Now on top of my cutting die, it'll range. It says, it shows the 1 1/8", and it shows 2 inch here. And I can move this by pulling back this lock and going to the appropriate pipe size by aligning the lines on the gauge. This is 2 inch. Now there's a pretty good chance that when I thread this pipe, that the fitting is not going to go on sufficiently to obtain a seal. So I will have to reduce this by moving it forward. Right here, there is a little clip that prevents you from pulling this slide all the way back. If you pull this slide all the way back, these dies will fall out. And then you will have the pleasure of removing the dies and placing the dies back into their slots. They're numbered 1 through 4. These are also numbered 1 through 4. To replace them or to reinstall them, you would simply loosen this up, move the clip out of the way, go all the way to its back setting, and these will slide out. And then you will slide them in, and there's a little line that tells you where to stop, and you will place them on the line, and then rotate the assembly forward until the cams interlock into the grooves that are machined into your dies. It is not a lot of fun, to forewarn you. So I say that to say this: when you are using this machine and making adjustments, not intending to remove the dies, do not extend past this clip and ensure that this clip is in place. Now return it to the carriage. I place it down. And again, this is a free floating machine. I'm at the 2-inch mark. As I previously stated, everything that is moving away from me takes it out of service. Everything coming towards me places the machine in service. That is inclusive to the cutting dies. When I pull this lever forward, you can see the dies close. When I push the lever forward, the dies open. So I'm at my 2-inch. I'm locked in place. And I will step on the machine. Once again, I will verify lubrication. Without lubrication, you will eat up a set of dies, and they are not cheap. I will engage via the hand wheel. Once the threads start, I no longer have to apply pressure. You can hear the machine motor bog down. That tells me it is engaged. I want to run the full 1 inch of die, which gives me 10 threads. This die is rated at 10 threads per square inch. When I reach the end of my die, I simply lift the lever out of the way, and it is free floating. Why do I do that instead of just let off? Because as it's spinning, all those metal shavings that are standing up, majority of them will break off for you. Now I will move this out of the way, wearing gloves so I don't get cut. I'll check my threads. My threads are clean. Sometimes you can engage the machine and just take your rag, clean out all those metal shavings. Because what those metal shavings will do, when I go for my second pass, it'll gum up the threads and create misalignment for the threads. Now I want to check. I need 3 to 5 threads sticking outside, 3 to 5 threads sticking inside, which I would then give myself a 1/2 inch takeoff for this, which we've disclosed in the previous video. Now, there are 10 threads inside this fitting. I want to go halfway to ensure that my taper has achieved a seal. So what I'll do is I will test fit it. And I should be able to get 2 or 3 turns. Let's see, I'll move this out of the way because of the 90. The Rigid 535 has a nice little workbench up here where you can place your pipe wrenches, you can place your tools, your fittings, things that you're going to be utilizing temporarily. And I'll get 1, 2. It's almost there. Now I can count. I have 1, 2, 3, 4, 5. I have 6 threads. I'm probably going to get another couple of turns with my pipe wrench. So that would actually be very, very satisfactory, if not optimal, for this threaded fitting. All of these threaded fittings that you use, just because it's a 2-inch, does not necessarily mean that every one of them is going to be identical. It depends on how they were machined, how close the tolerances were. They could vary anywhere from 10 to 12 thousandths from the inside of your thread pitch. And that is how we thread the deburr and cut on a Rigid 535M pipe threading machine. I thank you for your time, and I look forward to seeing you in pipe fitting.
Thank you for watching our video today. I hope you enjoyed it. I hope you learned something today. If you would like to get some more tips and tricks and become a better welder, then subscribe to our channel. And if you would like to learn even more right now, then click on our link. Thank you, and we'll see you next time.